Learn how to enhance the performance of Python applications using MongoDB and Redis for efficient data handling and fast data retrieval. Did you know that optimizing Python applications with the right databases can supercharge your performance? Today, we'll delve into how MongoDB and Redis can be game changers for enhancing Python efficiency. Whether you're dealing with vast amounts of data or need lightning-fast responses, these tools can be your secret weapons. Let's explore how you can harness their strengths to make your applications not just faster, but smarter too.
Let's dive into understanding the unique roles of MongoDB and Redis. MongoDB is a NoSQL database that's perfect for handling large volumes of data with its flexible schema design, making it ideal for applications that require scalable data storage. On the other hand, Redis is an in-memory data structure store, known for its exceptional speed, making it suitable for caching and real-time analytics. Both have their strengths. MongoDB excels in handling unstructured data, while Redis is unbeatable in low-latency data retrieval. By leveraging both, you can optimize your Python applications for enhanced performance. Setting up your environment is the first step to optimizing your applications. Start by installing MongoDB and Redis. MongoDB can be easily installed via package managers or Docker, and Redis follows a similar process. Next, ensure your Python environment is ready. Use virtual environments to manage dependencies, and install necessary libraries like PyMongo for MongoDB and RedisPy for Redis. Connecting Python to these databases is straightforward. Use connection strings for MongoDB, and Redis connection configurations for Redis. Remember, proper configuration is key to ensuring seamless integration and optimal performance. MongoDB's strength lies in its ability to scale. Start by designing a flexible schema that can adapt as your data grows. Use indexing to improve query performance significantly. MongoDB supports various index types, so choose the one that fits your use case. Sharding is another powerful feature, allowing your database to handle massive datasets by distributing them across multiple servers. Additionally, MongoDB's replication capabilities ensure high availability, reducing downtime. However, be cautious of common pitfalls like over-indexing or ignoring schema design principles, which can lead to performance issues. Redis is renowned for its speed, making it an excellent choice for caching. By adding Redis as a cache layer, you can drastically reduce the load on your primary database. Redis offers versatile data structures like strings, lists, and sets, which can optimize data retrieval processes. Implement caching strategies by identifying frequently accessed data and storing them in Redis. For persistence, configure Redis to save snapshots or use append-only files. To maximize performance, monitor Redis operation metrics and adjust configurations such as max memory usage and eviction policies.
Once your setup is complete, the next step is writing efficient Python code. Start by crafting effective data queries that minimize load time. Consider using async libraries like Asyncio to handle multiple operations simultaneously, reducing wait times. For large datasets, batch processing and bulk operations can be more efficient than handling records individually. Optimize network calls by minimizing round trips and using connection pooling. Finally, implement robust error handling to manage exceptions gracefully, ensuring your application remains reliable even during unexpected failures. Integrating databases with Python can be challenging if not done carefully. One common pitfall is misunderstanding data consistency requirements, leading to potential integrity issues. Avoid overusing complex database features that can complicate your architecture unnecessarily. Properly manage database connections to prevent leaks and ensure efficient resource utilization. Regularly monitor database performance metrics to identify potential bottlenecks early. Lastly, implement robust security measures, such as encryption and access controls, to protect sensitive data from unauthorized access or breaches. Let's look at real-world scenarios where MongoDB and Redis have made a significant impact. In an e-commerce application, integrating Redis for caching drastically improved response times during peak load periods, ensuring smooth user experiences. MongoDB's sharding capabilities allowed the application to scale effortlessly as the user base grew, reducing pressure on database resources. These optimizations not only enhanced performance but also proved cost-effective, as they minimized the need for additional infrastructure investments. Such examples highlight the tangible benefits of leveraging these databases for Python applications. As technology evolves, so do the trends in database integration with Python. Multi-model databases are gaining traction, offering flexibility by supporting various data models. Python's data ecosystem continues to expand, with new libraries and frameworks emerging to handle complex data requirements. Real-time data processing is becoming essential, driven by the need for instant analytics and decision-making. Additionally, the integration of AI and machine learning with databases is on the rise, enabling more intelligent data interactions. Staying ahead of these trends will ensure your applications remain competitive and efficient.
In conclusion, optimizing Python applications with MongoDB and Redis can significantly enhance performance and scalability. We've covered strategies from setting up your environment to implementing efficient code and avoiding common pitfalls. Now it's your turn to experiment and see the results firsthand. Share your experiences in the comments, and don't forget to subscribe for more insightful content. If there's a topic you'd like us to cover next, let us know. Together, we can continue to push the boundaries of what's possible with Python and databases.